Back on the oxygen and pressure curve, up to this point, what we've learned is that what's most important is the number of molecules of oxygen getting into our lungs. And that is best represented by the partial pressure of oxygen in the lungs. And that is what's critical. And that overall, we do well up to 10,000 feet before most people will start to get symptomatic. We've also learned that supplemental oxygen with very specific equipment can help raise that altitude limit all the way up to 39,000, 40,000 feet, depending on what you're using. But what else can impact this oxygen dissociation curve? So you're going to see on the graph here, pH. So pH is representing acidity. So a normal pH for human blood is around 7.4. But the more acidic blood actually reduces hemoglobin affinity for oxygen, while less acidic blood will raise the affinity. Now, why is that? If we think about it, this is kind of the natural cycle of how our body is working. So our muscles are working and performing work and doing things, but let's use an extreme example. So there's two types of muscle work. So there's aerobic and anaerobic. Now, aerobic is the one where we preferentially burn oxygen as part of the fuel source process, and it creates very little waste in our body. But anaerobic is that very short burst where we need a lot of energy in a very short amount of time, and our breathing can't necessarily keep up with that. And that's when we're burning sugar, and that burning of sugar creates lactic acid. That's that muscle burn. If you go do a sprint or you lift heavy weights, that lactic acid is causing that muscle burn. Now, that muscle burn is from that lactic acid, which has now increased your acidity, which lowers that pH number, if you remember back from high school chemistry. So as that pH number gets lower, now your blood has a lower affinity of oxygen. And that's good because your muscle tissue actually needs that oxygen more. So that helps the blood offload the oxygen into your muscles at a faster rate. Meanwhile, as the carbon dioxide gets attached to your blood and moves off to your lungs, what we're doing there is we're off-gassing that carbon dioxide, and that is reducing the acidity, so raising that pH number. And that means we're getting rid of that carbon dioxide, and now our blood has a higher affinity for oxygen. So this helps accelerate the absorption and transfer of oxygen through various parts of the body and back to the lungs.